I am UMANG, a master's student in RWTH Aachen, Germany. I am doing my master's in railway system engineering. I will be trying to explain big railway concepts in simple words with examples. So today's question and the first question is, how do trains take a turn? So this is a turn. Now there are two forces. One force which is pulling the train inwards, that is the centripetal force, and one force that is going outwards, that is the centrifugal force. As I promised you, I will be explaining the force simply. So this is a string and we have tied the object to its end, as you can see. So now I am turning it, I am rotating the string in my hand. The object is trying to fly outwards, but my hand is preventing it. But what if it breaks suddenly? What if the string breaks suddenly? It will fly outwards. Now if you see it from my point of view, I am rotating the string and the string or my hand, we feel an inward force, like we are trying to pull it. But if you see it from the object's point of view, it will try to fly outwards. My hand is and the tension in the string, it is what preventing him from it. So if you go in a circle, there will be an outward pull, which is called as a centrifugal force. But there will be a counter force. It is a centripetal force which will try to pull it inwards. Now let's take another example. We see a car. Now if we take a turn slowly, nothing happens and a car is able to turn. But what if we take a turn very fast? The car will roll and it will be only on its outer wheels. But unlike cars, here we don't have roads, but we have fixed rail lines. So how will we come across a solution? So the solution is building a slope. We see that the inner part is on the ground, but the outer part is at a bit of a height. So this is a slope that we build since the train is trying to roll outwards. Now if you look in this figure, we see this train and we see this slope. So now there are two forces. The force which is pulling the train inside and the force which is pulling the train outside. Now the force which is pulling the train outside is mv square by r, where m is the mass of the train, v is the speed of the train, and r is the curve radius. So this is the curve radius, the radius of the turn. So I won't go deep into maths, but I will just look into small numbers to explain you the concept. So as I see, there are two forces, outside and inside. So the remaining force is force outside minus force inside. Now if you look in this diagram, we see that the train is a bit tilted. So this force downwards is the gravitational force, which is divided into two parts, and this force here is the outside force, which again is divided into two parts. So now again coming to the maths, so force outside minus force inside. Now force outside is mv square by r, as I already discussed, but we see we have to take the cost component of it. We are considering this force and this force. So considering those components, it's mv square by r cos alpha minus mg sin alpha. Now we want no remaining force, so we'll consider it as 0. So force outside should be equal to force inside. Now how do we make it possible? We equate both of them. So mv square by r cos alpha is mg sin alpha. Now we'll cancel m on both the sides. So we are left with v square by r cos alpha is equal to g sin alpha. Now we see cos alpha is nearly equal to 1. So we can consider cos alpha as 1. And for sin alpha, we look at this figure. So in this figure, we see D is track gauge. Now this is the distance between the two railway wheels and h is the height of the slope. So when we take sin alpha, we come across h by d. So now v square by r and cos alpha is 1, so nothing. So v square by r is equal to g h by d. So if we need the height h, it comes as v square into d divided by r into g, where d is the distance between the two wheels and h is the height of the slope. So we saw the formula, h is equal to v square into d divided by r into g. Let's take a radius of turn as 500 mm. Gravitational force is 9.81 meter per second. I am sorry, radius is 500 meter, not mm. Speed is 60 km per hour and d is 1.435 meter. That is the standard track gauge. Now if we substitute, we will get the answer is 81.20 mm. Just take care of the units. You need to convert everything into mm. Just like the car, if a train goes very fast in a turn, it would roll on its outer wheel. So that's why we have the slope or cant to prevent it. Very simply, the outer wheels try to lift upwards, but we are enabling it to lift upwards, so there is no passenger discomfort. and the train won't roll. All the wheels, that is the wheels on the inner side as well as on the outer side, would stay stuck to the ground or the track. So if you look at it, 81 mm is okay. Now let's say if the train is going at 300 kilometers per hour. Then if you take the value of 300 kilometers per hour and keep in this equation, keeping all values as constant, we get a height of 2031 mm. That is nearly equal to 2 meters. Now as you saw, you got a cant of 2000 mm, which is not possible. There are certain rules and regulations. In Germany, you have a cant height of at least 20 mm. You can't get a height of 8 mm or 10 mm or 15 mm. It should be at least 20. And the maximum height is 160 or 170 mm depending upon the type of track. So how do we solve it? Now in the previous equation we saw that Fr, we equated it to 0. Now it should not necessarily be 0. It can be up to a certain value. So now our force up to 1 meter per second square is acceptable. So that depends upon passenger comfort. Up to 1 meter it is okay for him. Now the another factor is radius. In the earlier sum the radius was 500 meter. But generally when the train runs up to 200, 300, 400, the radius is nearly 300 or 400 meter. If we just turn the formula a little bit, keeping h down and r up, then we see that radius is v square by d hg. So depending upon the height, we can get the radius. So you would ask me why we have such a small height. So the issue is that when we want to increase the height, we can't increase it suddenly. So we have to increase it slowly and then it will be up to 2000 meters. So if you need to go up to 2000 meters, you need to keep a very large amount of length, that is a ramp, which is not possible. Another issue is that when the slope ends and when the train has to be normal, the track has to be normal, then there is a chance of derailment. In each video, I will try to include a fun to do quiz which you can try yourself to understand the concept better. So here is the fun to do thing for this first video. So the thing to try at home is the equation of the outer force, that is m into v square divided by r. So if the mass is high, then there will be a greater outside force. Also, if the vehicle is going at a greater speed, derailment. So you need to go at a slower speed. So if the vehicle is going at a greater speed, then the force will be higher. But you see that the equation you divided by the radius. So if the radius is much higher, then your train is able to go at high speeds without being derailed. So try it yourselves. Take a rope and tie a small object to it. Try to rotate it slowly. Now take a bit heavier object and try to rotate it at the same speed. You will see that you need greater force. Now again, if you rotate it slowly and throw it, it will go only a little bit away. But if you rotate it very fast and you throw it, it will go at a greater distance. Another thing you can try is when you're taking a turn with a scooter or somewhere, try taking a very sharp turn. You will see it takes more effort. But if the turn is a bit longer, then you're able to take it easily. So same you can try with the rope. Take a smaller rope and see how much force you get, and take a bigger rope but rotate it at the same speed and see how much force you need. If the rope is bigger, then you will need a lesser force. Try it yourself and let me know how was the experience. So now you know how a train takes a turn, and sometimes if you feel a jerk, you will understand why. I want to make this video to be understood by an engineering and non-engineering student. So do let me know how did you like it, and also let me know what question do you have. I will try to answer it in a simple way.